Hello everyone, welcome back to Lulumath. Today we're going to talk about factoring completely, and this is the culmination of all the factoring that you need to know how to do. Because it's a culmination of everything that we've done so far, pretty much all the factoring videos that we've looked at are required in order to be able to know how to factor completely. So you need to know how to factor by GCF. You need to know how to factor differences of perfect squares. You need to know how to factor trinomials. And there are 3 separate videos on it. You can either do it by unfoiling, using the geometric or the box model, or by decomposition. And you also need to know how to factor by grouping. All of these videos are available at lulumath.com or at the Lulumath YouTube channel if you want a refresher. All right, let's get into it. So before we do anything at all, you always want to ask yourself the following questions whenever you are factoring. You're going to ask yourself, is there a GCF? Is there a difference of perfect squares? Is it a factorable trinomial? Can I factor by grouping? And is it completely factored? And this last question is super important because a lot of people will forget to ask themselves this last question, and then their final answer is not completely factored. And sometimes we're going to have to go through this list multiple times. For our first example that we have here, we're asked to factor 5x squared plus 75x plus 180. So the first thing we're going to ask ourselves is there a GCF? And yes, there is a GCF. Our GCF here, we've got 5x squared, 75x, and 180. There are no variables in common, but there is a number in common, and that number is a 5. I can divide all of my terms by 5. So the first thing I'm going to do is factor by GCF. So when I factor out the 5, when I divide 5 into 5x squared, I end up getting x squared left over. When I divide 75x by 5, I end up getting 15x. And when I divide 180 by 5, I end up getting 36. So we've asked ourselves our first question, we're done with it. Now for our second question, we're going to ask ourselves, is it a difference of perfect squares? Well, in order for it to be a difference of perfect squares, it needs to satisfy 3 conditions. Remember, it needs to be a binomial. It has to have 2 terms. It has to have subtraction. It has to be a difference. And it has to have perfect squares. So I'm going to look at what I have in my brackets or my parentheses here, this x squared plus 15x plus 36, and I can already tell that it's not a difference of perfect squares because it's not a binomial. Binomial, remember, means it has to have 2 terms, but we have 1, 2, 3 terms here. Therefore, it is not a difference of perfect squares. So now I want to know, is it a factorable trinomial? If I look right here at what I have inside of my parentheses or my brackets, it's a trinomial. So that sounds promising. So I'm going to try to see, can I factor it? Remember, the first term in each binomial will multiply together to give us x squared. And the only options I have are just x multiplied by x. Now, the last terms will multiply together to give me this 36 right here. So I will make a list of factors of 36. So I can do 1 and 36. 36 is divisible by 2. So 2 times 18 will give me 36. I can do 3 times 12. I can do 4 times 9. I can't divide 36 by 5, and I can divide 36 by 6. I get 6 and 6, and that's my completed list because I've gotten to a point where I have repeats. Can any of these numbers give us this 15 that we're looking for? Yes, we can get 15 from this 3 and this 12. So if I put a 3 here and a 12 here, my outer x times 12 is 12x. My inner 3 times x is 3x, and it works. It gives me 15x if both of them are positives. This positive 3x tells us this 3 is positive, and this positive 12x tells us this 12 is positive. Do not forget to bring down your GCF. So it is a factorable trinomial. Check, we're done with that. So we can move on to the next question. Can I factor by grouping? Well, if I take a look at each one of my factors here, I've got 5, which is a prime number, so I can't even factor that any further. It's also a monomial, so it's not factorable any further than that. I've got x plus 3, which can't be factored by grouping, and I have x plus 12, which can't be factored by grouping. Our last question is asking us, is it completely factored? So in order for us to know if it's completely factored, we need to look at each one of our factors. So our 5, our x plus 3, and our x plus 12. And we're going to go through our list again and see if any of these questions can be answered again. Is there a GCF for this 5? Well, it's only a monomial, so I can't take out a greatest common factor from just one number. There's no GCF between the x and the 3. There's no GCF between the x and the 12. So we've gotten to a point where this is officially no longer a possibility. Is it a difference of perfect squares? So this 5 is a monomial. It's not a difference of perfect squares. This x plus 3 is a binomial, but there is no subtraction, and neither one of these terms is a perfect square. Same thing with this x plus 12. There is no subtraction, and neither one of my terms is a perfect square. So this next question is a definite no as well. Is it a factorable trinomial? Well, 5 is a monomial, x plus 3 is a binomial, x plus 12 is also binomial, so that is not possible. I cannot factor by grouping. We've already asked ourselves this question for each one of these factors here, so it is not possible to factor by grouping. We've gotten to a point where it's completely factored because none of these is possible anymore, making 5 times x plus 3 times x plus 12 our final answer. For our next example, we want to factor negative 12x to the power of 3y plus 26x squared y minus 10xy. And we're going to go through this list of questions again. So our first question is there a GCF? So looking at what we have here, our coefficients are all even numbers, which means that they're all divisible by 2. So we know for a fact that there is going to be a GCF. Now, because our leading coefficient is negative, that means that our GCF is going to have a negative in it. So negative 2 is at least the first part of my GCF. There are also variables in common. So if you look here, we've got x to the power of 3, x to the power of 2, and x to the power of 1. And remember, we look for the smallest exponent, so we're going to use x to the power of 1 right here, or just x. We also have y's in common with each one of our terms. So y will also be part of our GCF. Now, when I factor that out, negative 12 divided by negative 2 is positive 6. X to the power of 3 divided by x is x to the power of 2. Y divided by y cancels. Now, 26 divided by negative 2 is negative 13. X to the power of 2 divided by x to the power of 1 is x. Our y's cancel out again. And then negative 10 divided by negative 2 is positive 5. X divided by x cancels, y divided by y cancels to give me 1 for both of those, but 5 times 1 times 1 is simply 5. So we finished our first question for right now. The next question is it a difference of perfect squares? Well, looking at my two factors, this is a monomial, and this is a trinomial, and because the difference of perfect squares needs to be a binomial, we can conclude that it is not a difference of perfect squares. Then we're going to ask ourselves, is it a factorable trinomial? Looking at our first factor, it is a monomial, but looking at our second factor, we have a trinomial. So we're going to try to see if we can factor this. Now remember, our first term multiplied by our first term will multiply together to give us the 6x squared. So we will make a list of factors for 6. We can do 1 and 6, or we can do 2 and 3. We also know our last terms will multiply together to give us this 5. So making a list of factors for 5, we can do 1 and 5, and that's it because it's a prime number. So I'm going to try to place a 2x here and a 3x here. I just feel like trying 2 and 3, and I will put my 5 here and my 1 here, and I'm going to see what I end up getting. So when I do my outer, 2x times 1 is 2x. When I do my inner, 5 times 3x is 15x. I can get a 13x if the 15 is negative and the 2 is positive, making this 1 positive and this 5 negative. However, negative 5 times positive 1 gives us a negative 5, not a positive 5, so this combination will not work. So let's go ahead and try to swap the 1 and the 5. So I'll put the 1 here and I'll put the 5 here. So my outer 2x times 5 is 10x. My inner is 1 times 3x, which is 3x. And if they are both negatives, then I can get negative 13x. Since this 10x is negative, that tells us that this 5 has to be negative. And since this 3x is negative, that tells us that this 1 has to also be negative. And again, don't forget that you always have to bring down your GCF. So I've got negative 2xy in front. So we're done with this step. It's a factorable trinomial. I'll set with that. Then I'm going to ask myself, can I factor by grouping? So in my first factor, negative 2xy, I can't factor that by grouping. This 2x minus 1 can't be factored by grouping because I need at least 4 terms to be able to factor by grouping. Same thing with this 3x minus 5. Therefore, I can't factor by grouping. Then I'm going to ask myself, is it completely factored? So I'm going to go through my list again and make sure that there's nothing else I can do with each one of my new factors that I have here. So again, this negative 2xy, there's no GCF. It's not a difference of perfect squares. It's not a trinomial, and we already said we can't factor it by grouping. For 2x minus 1, there's no GCF. It's not a difference of perfect squares because 2 is not a perfect square, x is not a perfect square. It's not a factorable trinomial because it's 2 terms and not 3, and we already said we can't factor by grouping. My last factor, this 3x minus 5, there's no GCF. It is not a difference of perfect squares because 3 is not a perfect square, x is not a perfect square, and 5 is not a perfect square. It's not a factorable trinomial because it's 2 terms as opposed to 3, and we already established that we can't factor it by grouping. Therefore, it is completely factored. So this tells us negative 2xy multiplied by 2x minus 1 multiplied by 3x minus 5 is our final answer. All right, we're now to our last example that we have here. I'm going to go through my list of questions. First, I'm going to ask myself, is there a GCF? So looking at all of my terms, I can see that there are no coefficients in common. However, there are a's and b's in common. So there is a GCF. And since there are a's in common, I'm going to look at all my exponents. So I've got a to the power of 3, a to the power of 2, another a to the power of 2, and an a to the power of 1. Looking at these exponents, I can see that a to the power of 1, or just a, is going to be my GCF because, again, we look for the lowest exponent that's in common. Let's do the same thing with our b's. So we've got b to the power of 2, another b to the power of 2, a b to the power of 1, and another b to the power of 1. So that tells us that b to the power of 1 is going to be a part of our GCF. Then looking at the C's, there are only C's in my second and my fourth term, but because it's not in common with all 3 terms, C is not part of my GCF. So when I factor out an AB from my first term right here, a to the power of 3 divided by a to the power of 1 will give me a to the power of 2 because we subtract our exponents when we divide, and b to the power of 2 divided by b to the power of 1 is just b. Now, when I divide 3a squared b squared c by a to the power of 1 b to the power of 1, I get a positive 3, and then a squared divided by a is a, b squared divided by b is b, and then this c is being divided by an invisible 1, so c divided by 1 is just c. Now, for my next term, negative 5a squared b divided by ab, I end up getting negative 5, a squared divided by a is a, b divided by b is 1, but a times 1 is just a, so I can write down negative 5a. And then for my last term that I have here, negative 15abc, I'll end up getting negative 15, a divided by a cancels, b divided by b cancels. They both give me 1, but negative 15 times 1 is just negative 15, and then there is a c left over. So yes, there was a GCF, and we are all done with this step right here for now. Okay, now our next question is it a difference of perfect squares? So I'm going to look and see each one of my two factors here are either one of those perfect squares. So looking at my two factors here, are either one of these difference of perfect squares? Well, AB is a monomial, so it is not a difference of perfect squares because a difference of perfect squares requires two terms. And then this bracket right here, this set of parentheses here contains 4 terms, therefore it is not a difference of perfect squares. Now I'm going to see, is it a factorable trinomial? Same thing, the first factor is 1 term, so it is not a trinomial, it's not 3 terms. And my second factor is 4 terms, so again, it's not a trinomial, so it's not a factorable trinomial. So the next thing I'm going to look for is, can I factor by grouping? If I look at my first factor, I can't factor that by grouping again because it's just a monomial. But in my second factor that I have here, I have 4 terms, which means that I can group them together. I'm going to put a squared b plus 3abc together as one group. And then I will put negative 5a minus 15c together as another group. Now don't forget that you have to bring your GCF down, so don't forget to bring down that AB. Taking a look at my first group that we have here, they have an A and a B in common. So I'm going to factor out an AB. And when I do that, when I factor it out of my first term here, I have an A left over. And when I factor it out of my second term here, I have a 3C left over. And I will close that bracket. Now I'm going to do the same thing with my second group. Now there's a leading coefficient of a negative number. So I'm going to factor out a negative 5 because that's in common with both terms, and there are no variables in common. So when I factor out negative 5 from negative 5a, I have an a left over. And when I factor out negative 5 from negative 15c, I end up getting a positive 3c, and then I close that bracket. However, we have another set of brackets that we have to copy down because this GCF of AB still has to get brought down. I'm not allowed to change my expression at all, and it's AB multiplied by this entire expression here. All right, let's keep factoring by grouping. If you see, there is an A plus 3C in common, so I'm going to factor out this A plus 3C right here. I'm going to close that bracket. When I factor that out, I have an AB left over here, and I have a negative 5 left over here. So I've got minus 5 right here. Don't forget to bring down this AB. Now we don't need a second set of parentheses here or a second set of brackets because my 3 factors are separated by multiplication, so it's not necessary. However, if you want to include it, you can. So we've gotten to this point right here, and I want to see, is this completely factored? So I'm going to go through my list of questions for each one of my 3 factors and see if I can take it any further. So my first factor is AB. There is no GCF because it's a monomial. It's not a difference of perfect squares because it's a monomial. It's not a factorable trinomial, again, because it's a monomial. And I can't factor it by grouping because with monomials, there's nothing to group. So my second factor, this A plus 3C, I'm going to go through my list again. Is there a GCF? There's nothing in common with A and 3C. Is it a difference of perfect squares? No, it is not because there's addition and we don't have any perfect squares here. Is it a factorable trinomial? It is not because it's a binomial and not a trinomial. Can I factor by grouping? It is only 2 terms, and so I can't really group anything together. So this factor here is completely factored. For our last factor that we have here, there is no GCF because nothing is in common with the AB and the negative 5. It is not a difference of perfect squares because although there's subtraction and although it's a binomial, AB is not a perfect square and 5 is not a perfect square. It's not a factorable trinomial because it is a binomial, and I can't factor it by grouping because there are only 2 terms. So the answer to this question of whether or not it is completely factored is yes, because I can't take any of my factors any further. Therefore, AB times A plus 3C multiplied by AB minus 5 is my final answer. Thank you for watching this video. If you have any questions, please let me know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If you found this to be helpful, please make sure to subscribe and share with others. Thank you, have a great day, and we'll see you next time.